What I'm going to do now is I'm going to use the same apparatus to investigate the current going around a parallel circuit. So what I'm going to do is first of all just build my parallel circuit. So I'm just going to connect in an ammeter here. And I'm going to connect in an ammeter here as well. And as before, at the moment, we've just got one loop here. We haven't got multiple branches, so this is just starting off with a series circuit. And the current is the same going into the lamp as coming out of the lamp. What I'm going to do now is I'm going to add another branch into here and see what effect that has on my circuit. So let's put another lamp in here. And I'm going to add another ammeter here as well. So what I've got here is I've now got two parallel branches. So I have one route for the electric current to go around in this direction, like so. But also the electrons can go in this direction around the route here as well. One thing that you can hopefully see is that the current through each of the branches, so the current through this lamp is 0.1, the current through this lamp is 0.1 or just over 0.1, 0.11, and the current through here, which is measuring the current coming out of the power supply, is 0.2, which is the current going through both branches added together. So all of the current that goes through this branch plus this branch has to go through this ammeter. So the current is leaving here, going through there. Some of it goes in that direction through this lamp, and some of it's going through this lamp here, like so, and coming back. But if you add that current from this lamp and this lamp together, you end up with the current coming out of the power supply, the 0.22. So this current equals that plus that. We could actually test that by putting a third loop in there as well. So I've now got three lamps all in parallel. So there's some current leaves and goes in that direction, some comes through here and some comes through here. And what I can see is that this current, 0.1, 0.1 and 0.1, but if I look at the current here that's coming through the power supply, 0.31. So the current from each branch adds up to the current that's leaving the power supply. I'm going to look at the current in a parallel circuit. So at the first one is very similar to, well, it is a series circuit. So we've just got our one lamp. And again, the current is 0.1 going in and 0.1 going out. But what I'm going to do now is I'm going to add a second branch onto our parallel circuit. So here's our second lamp, and it's now in parallel. I'll put another ammeter there and then join it back on. So what we found was that the current through this lamp is still 0.10 amps. That's not changed, and in fact the current here is 0.10 amps as well. But the current through here is 0.20 amps. So the current has doubled going here, and it's 0.1 and 0.1 there. And if you think about the route that the electrons or the current can take around the circuit, that makes sense. So let's follow the current that's going to go through this bottom lamp. So I'm going to draw that in this pink. And that current is going around the circuit like so. And now I'm going to draw in the current that's going around the second lamp, and it leaves and it goes along here, and then it comes down and back. And so what you see is that all of the current, the pink and the green, is going through this ammeter, so that's 0.1 amp and 0.1 amp, so 0.2 amps, but only the current the only current that goes through this ammeter is the one that's following the pink route, which is 0.1 amps. And the only one that goes through this ammeter is the one following the green route, which is 0.1 amps. And again, we can check that by putting in another lamp into our parallel circuit. So we've added another lamp in parallel over here, and the current through this route is 0.1 amps as well. And what that means is that we've now got a current here of 0.3 amps. So we now have a third route that the electrons can follow, and that's shown by this blue line. And once again, all three, the pink, the blue, and the green, all go through this 1 ammeter. So that is the total 0.1 plus 0.1 plus 0.1 is 0.3. We could check that, and indeed we did. We put an ammeter here. So if we when we put an ammeter here, what we found was that this ammeter is recording all the current that's going through the green and the blue route. So that came out to be 0.2 amps. So it didn't record what was going through the pink. It only recorded what was going through the green and the blue. One thing to realise is that electrons have no intelligence. They don't make decisions as to where they're going to go based on whether a route's easier or more difficult. The only thing that influences the amount of current through this branch is the resistance in this branch. And if I broke this branch, this lamp broke, so say that lamp blew, this current would stop flowing, so there'd be no current there, but these two would still allow electrons to go through, and they wouldn't allow more electrons. It would just mean that the whole current had reduced, so this would no longer be correct. This would have gone down to 0.2 because no current is following the pink route anymore.